Okay, so today the notes are talking about equations with radicals. Radical is another word for the root, the square root symbol. So I'm going to write it over here to the side. Square root just is the opposite of taking something to the second power, and clearly there are other roots, so you could potentially take something to the third power, or you could take it to the fifth power. And so just in general, all of those are considered radical signs, or the radicals. So there's a couple of steps up here. It's very similar to how we've done the previous things, where you notice that it's asking you to isolate the radical, which is kind of like your grouping symbols. So you're going to isolate that part first and get it alone on one side of the equation, and then you're going to undo the radical symbol. And so let's give an example of how that works here. So the radical piece is this right here. So I need that to be the only thing on the left side of the equation. And so you can see that there's a plus 7 right there. So we're going to go ahead and subtract 7 from both sides, just like we would if that had been a regular, like, let's say 5x. So we're going to go ahead and do the math. And so we still have the square root of x plus 5, and it equals 5. So now to get rid of the square root, you have to take it to the second power. So now we have the second power canceling out the square root. So those would cancel, and we'd be left with x plus 5 equals 25. And now clearly that's just a one-step equation. So you're going to subtract your 5, and you're going to end up with x is equal to 20. And so there's my final answer. Question 2 is practically the same thing. In fact, it's probably a little easier to see that that plus 4 is not part of the square root than it was on our original problem. So again, you're going to just go ahead and subtract your 4 from both sides. You have h plus 1 inside the square root symbol is equal to 10. Again, let me switch colors. You're going to take both sides to the second power, and so the second power cancels out the square root, and I'm now left with h plus 1 equals 100. Clearly, you're going to subtract your 1, and you're going to get an answer of 99. So fairly straightforward. I haven't mentioned the check yet, which is the last step. You want to double check that you have a solution that actually works inside. And I'll be honest, when the answers are positive and I know I'm adding inside the square root, it's really not a problem because clearly 20 plus 5 works out to a positive number. Let me go down and talk about extraneous solutions, and so we can kind of see that. So if we look here, specifically number 1, can we think of a number that you could put inside the square root that would end up giving me a negative 5? Well, probably not. What we can figure out is we know that 25, the square root of 25 is going to give me 5. But it isn't going to give me a negative 5. Do you see how that? It's not possible, because clearly anything to the second power is going to be a positive answer. So when we get a solution like this, what we're going to know is that it is impossible. So this has no solution. Now sometimes they're obvious, like this one, where clearly when you square them, we can't work it backwards. Sometimes they're not as obvious. So let's look at this one. If we just eyeball it and look at it the same way we did number 1, it would look like it would be an extraneous solution. But let's just check it to make sure. So clearly what we're going to do is we're going to go ahead and square both sides like we did before. And so that was going to give me x minus 5 is equal to negative 1 times negative 1 is positive 1. So I'm going to go ahead and substitute in here, and I'm going to get an answer of x is equal to 6. Now here's how we're going to check to see if that makes sense. can I put a 6 minus a 5 in? And am I going to be able to get it to equal to -1? So clearly that is 1. And if you do that, it's clearly not going to work out nicely. So you cannot have a square root that is going to equal a negative number of any sort. There are some times when we get a solution that we put it back in and it doesn't actually work out correctly because of the way the square root is. So, for instance, let's look at 3 and 4 up here and see if we can make sure that they work. Because now we have, see how we have subtractions everywhere? Now I know I'm going to have to check my solution. So again, the first thing I'm going to do is I'm going to isolate the square root and see what has to move. So in question 3, again, it's very similar to the ones we did up above. Go ahead and add your 8. I get a positive 1. And again, we're going to take it to the second power. And that's going to give me a minus 5 equals 1. You add your 5, you get a is equal to 6. So we can check it out. If we have a 6 substituting right in there, we would have the square root of 6 minus 5, which is going to give me 1, which works out nicely. If for some reason this had not worked out to a positive 1, then you would have told me it was an extraneous solution. But this is my check right here. It does work out. It's going to work out nicely, so we're fine. All right, now question 4, what you're going to see is it's a 2-step. Unlike the ones that we've been doing so far, where they're really just a 1-step, we're going to do a 2-step on this one. So I'm going to do it like a regular problem. They're subtracting, so I'm going to add. Now again, just so you can see it, I'm going to go ahead and highlight it again, even though we're in the middle of the problem. See how the 2 and the square root are touching? That means that we're going to divide both sides by 2 so that we can get rid of that 2 out front. So now we have the square root of c minus 3 is equal to 6. And now we're going to square both sides. And now we have, and I'm going to see if I can't move it over a little bit. We're going to have c minus 3 is equal to 36. Let me make it just a little bit smaller so that we can show that last step. So we're going to go ahead and add the 3. That's going to give me c is equal to 39. And there's my solution. So again, nothing very different than what we've been doing. You just have to remember that all of those square roots, to get rid of them, you're going to take them to the second power. And if it had been a cube root, we would have done the same thing. We would have just taken everything to the third power. Okay, good luck on today's assignment.